Hi guys, in this video I will show you how to solve this equation which says the elliptical orbit of Plato has the greatest eccentricity among all planets of our solar system, which is equals to E 0.248. Plato's orbit has the Sun at one focus and a major axis of 79.6 AU, which is astronomical units. Consider Plato orbit on a giant coordinate grid where x and y are measured in AU and the Sun is at the origin, which means 0 coordinates, as shown in the figure above. So here it says use the length of the major axis to determine the value of A. So as given here, as we know, if you want to find A, and here is given us the major axis, which is 2A, we have to divide it by 2, which is equals to 79.6 divided by 2, which equals to about 39.8 U. Okay. And in this equation, use the eccentricity and A to determine the focal radius C. Round to 2 decimal places. Here he says he wants to find the C, the radius. And as we know from the general formula, C equals to here here is AE. Do you know why? Because the general formula states that C equals EA, and if you want to find E, we have to divide it by A both sides. Anyway, so E here is 0.248 multiplied by A, which is here 39.8, which is equals to 987 AU. Write an equation of the form here, this form, which is equals to 1 to module Plato's orbit. Find B first. So he says here we have to find B first. So first of all, let's find B. From the general formula that we know, it is C square equals A minus B square. So here the A and C is given, so we want to find B. If we want to find B, we have to divide A by C, or I mean minus them by together. So we have to minus A and C. B square equals to C square minus A square, and C square is what we got here previously, minus A square, which is this value here, and it will be about 14862. But here I did just a small mistake here, because this is small minus the big value would get us in negative, but ignore it, because you always have to minus the bigger value from the small value, and it will be about this. We have to square root it because we have B square here, and we will get B about 338.56 AU. And to find he says you want to find an equation, so if you want to find equation, we have to replace it by the general formula, which is x minus h square over a square plus y minus k square over b square equals to 1. And as was given here, as was given, he wants to know what is here. It says c, so here should be the value of c, which was 9.87 over a square. And what is a square was 39.82 plus y square 38.56 equals to 1. And after we find the square roots, it will be here square over here, it will be about 8404, and here it will stay the same, and here 14862 equals to 1. And this is the general formula. In this equation he says the perigee is when Plato is closer to the sun, and the apogee is when it is further from the sun. So the apogee from the graph should be here, the farthest distance, and the perigee is the closest distance, which is this one. So if you want to find the bigger value, we have always to find the apogee. We have to plus a plus c, because we want to find the bigger value here from the graph a plus c. So it is a plus c, and what was a is 39 plus c, which is equals to 49.67, and the perigee is the closest distance, so we have to minus it from the graph. When a minus c equals to the perigee. So just replace the givens, minus them, and it will be 29.93 AU, of course, AU. And that's it. This is how we solve this equation. And hopefully see you again. So have a good day.